Have you ever looked up at a giant skyscraper and wondered, how on earth does that thing stay standing during an earthquake? It seems like it should just snap and fall over, right? Well, it turns out, there's some incredible engineering magic at work that keeps these massive structures safe and sound, even when the ground is shaking violently. First off, skyscrapers aren't built to be completely rigid. That would actually be a disaster. Instead, they're designed to be flexible. Think of a tall tree swaying in a strong wind. It bends but doesn't break. Skyscrapers do the same thing. They're built with ductile materials, like special types of steel, that can bend and stretch without fracturing. This flexibility allows the building to absorb the earthquake's energy and sway back and forth, sometimes by several feet at the very top, without suffering structural damage. It's a bit like dancing with the earthquake instead of fighting against it. But flexibility alone isn't enough. To control the swaying motion and prevent it from getting out of hand, engineers use a clever device called a tuned mass damper. Imagine a gigantic, super heavy pendulum, often weighing hundreds of tons, suspended near the top of the building. When the skyscraper starts to sway in one direction, this massive weight swings in the opposite direction. This counter-movement effectively cancels out a lot of the building's motion, kind of like how noise-canceling headphones work, but for movement instead of sound. The famous Taipei 101 has one of the world's largest and most famous tuned mass dampers, and you can even go see it. Another brilliant technique is called base isolation. This involves constructing the building on top of special bearings or pads made of layers of steel and rubber. These pads act like a cushion between the building's foundation and the ground. When an earthquake hits, the ground can move back and forth aggressively, but the isolators absorb most of that shaking. The building above essentially floats on these pads, experiencing much less movement than the ground it's sitting on. It's like putting the entire skyscraper on a super advanced suspension system. So, it's not just one thing, but a combination of flexibility, giant counterweights, and clever isolation systems that keep our modern marvels standing tall. It is a testament to human ingenuity and our ability to build structures that can withstand some of nature's most powerful forces. Pretty amazing, isn't it? Thanks for watching, and if you learned something new, don't forget to hit that like button and subscribe for more.